Allotropes of carbon. Carbon exhibits many allotropic forms, both crystalline as well as amorphous. Well-known forms of carbon include diamond, graphite, ball-shaped Buckminsterfullerenes, and sheets such as graphene. Fullerene was discovered by H. W. Kroto, E. Smalley, and R. F. Curl. For this discovery, they were awarded the Nobel Prize in 1996. Diamond. Diamond is one well-known allotrope of carbon. The hardness and high refractive index of diamond make it useful for both industrial applications and jewelry. Diamond is the hardest known natural mineral and finds applications in cutting, drilling, and jewelry. In diamond, each carbon atom undergoes sp3 hybridization, and each carbon atom is covalently bonded to 4 other carbons in a tetrahedron having tetrahedral bond angles of 109 degree 28 minute. The C-C bond length is 154 pm. The structure extends in space and produces a rigid 3-dimensional network of carbon atoms. It is used as an abrasive for sharpening hard tools, in making dyes, and in the manufacture of tungsten filaments for electric light bulbs. Graphite. Graphite has a layered planar structure. In each layer, the carbon atoms are arranged in a hexagonal lattice with separation of 0.142 nm, and the distance between planes, layers, is 0.335 nm. Graphene is a single layer of carbon atoms arranged in one plane. Layers of graphene make up graphite. Graphene is a material of interest due to its high electron mobility and its possible applications in electronics. Graphite conducts electricity along the sheet. In graphite, all of the carbons are bonded to only 3 neighbors and are sp2 hybridized. As the sp2 hybridization results in planar structures, they are giant 2-dimensional layers of carbon atoms, and each layer is only weakly linked to the next layer by van der Waals forces. Graphite cleaves easily between the layers, and therefore it is very soft and slippery. For this reason, graphite is used as a dry lubricant in machines running at high temperature, where oil cannot be used as a lubricant. Fullerenes. Fullerenes are a class of carbon allotropes in which carbon takes the form of a hollow sphere, ellipsoid, or tube. Fullerenes are made by the heating of graphite in an electric arc in the presence of inert gases such as helium or argon. Fullerenes are cage-like molecules. A series of studies indicated that C60 and also C70 were indeed exceptionally stable cage structures. The smallest fullerene has 60 carbon atoms arranged in pentagons and hexagons like a football. This is called Buckminsterfullerene. Fullerenes were first isolated from the soot of chimneys and extracted from solvents as red crystals. Fullerenes are insoluble in water but soluble in methylbenzene. Buckminsterfullerene. Buckminsterfullerene or Bucky ball is a spherical fullerene molecule with the formula C60. It has cage-like fused ring structure which resembles a football made of 20 hexagons and 12 pentagons with a carbon atom at each vertex of each polygon and a bond along each polygon edge. All the carbon atoms are equal and they undergo sp2 hybridization. Each carbon atom forms 3 sigma bonds with other 3 carbon atoms. The remaining electron at each carbon is delocalized in molecular orbitals, which in turn give aromatic character to molecule. This ball-shaped molecule has 60 vertices and each one is occupied by 1 carbon atom, and it also contains both single and double bonds with C single bond C distances of 143.5 pm and 138.3 pm respectively. Minute quantities of the fullerenes in the form of C60, C70, C76, C82 and C84 molecules are produced in nature, hidden in soot and formed by lightning discharges in the atmosphere. Other forms of elemental carbon like carbon black, coke and charcoal are all impure forms of graphite or fullerenes. Uses of carbon. Graphite is used in steel processing, pencil lead and lubricant. Graphite fibers embedded in plastic material are used in products such as tennis rackets, fishing rods, aircrafts, and canoes. Being good conductor, graphite is used for electrodes in batteries and industrial electrolysis. Combining carbon with titanium boron, tungsten or silicon produces hard compounds. These types are utilized for grinding or cutting tools. Graphite crucibles are inert to dilute acids and alkalis. Activated charcoal is used in absorbing poisonous gases, also used in water filters to remove organic contaminators and in air conditioning system to control odor. Carbon black is used in black ink and as filler in automobile tires. Coke is used as a fuel and largely as a reducing agent in metallurgy. Diamond is a precious stone and used in jewelry. It is measured in carats. 1 carat is equal to 200 mg. The carbon diamond element has many industrial and commercial uses. It is the hardest known natural mineral. It is also considered as one of the most precious gemstones in the world. Diamonds are also used for cutting.